Welcome to lesson 3.5, reasoning with angles and triangles, reasoning with congruent triangles. So in the last couple lessons we talked about things that are congruent or the same. So each of these 5 triangles is positioned differently, but they all have the same size and shape, and you can pull out your ruler and protractor to confirm that. If they have the same size and shape and angles, well, they are congruent triangles. So this thing has just been, turned around. The diagrams below show the flags of some countries in the world and some Canadian provinces. All the flags shown have some features in common. Each flag contains triangles which are the same shape and size. 2 triangles which have the same shape and same size are said to be congruent. The flags of American Samoa and Namibia each contain 1 pair of congruent triangles. The flags of Scotland, Jamaica, and Nova Scotia all have 2 pairs of congruent triangles. The flag of Newfoundland has 1 set of congruent triangles and 1 set of 2 congruent triangles. On each of the flags shown above, mark 1 set of congruent triangles with the letter A and the second set with letter B. So let's look at Nova Scotia. Now, maybe a little bit difficult, but if we extended that triangle there and that triangle there, they would be congruent. So they are congruent A, and then these 2 are congruent, and we'll mark them with B. Newfoundland. So Newfoundland would be, we can mark these as congruent here, so B and B, and they're also congruent with those ones. And then these 2 are congruent here. American Samoa. You've got 2 that are congruent there. This is a triangle, but it's not congruent with any other triangle that's there. Namibia, you've got this one and this one are congruent. And Scotland, you've got those 2 are congruent, and those 2 are congruent. And the last one, Jamaica, is very similar to Scotland. Those 2 and those 2. So congruent triangles. A triangle has 3 sides and 3 angles. 2 triangles are congruent if all pairs of corresponding sides and all pairs of corresponding angles are equal. In the diagram, triangle PQR is congruent to triangle LMN. We write triangle PQR is equal to triangle LMN. Note that to describe congruent triangles, we write the corresponding angles in the same order. So you can't say angle P is equal to angle N because they're not the same angle, right? If this was turned around, this angle here, if it was rotated a little bit, you would have to adjust your thinking and know that whichever angle is the one that actually corresponds with the other angle is the one that you write together. So in here, angle P is equal to angle L, angle Q is equal to angle M, and angle R is equal to angle N. All right, so PQR is LMN. Also, side PQ is equal to side LM, QR is equal to MN, and PR is equal to LN. You do not need all 6 measurements in a triangle to prove that triangles are congruent. In the work below, we can show that in certain circumstances, only 3 measurements are required. So if you have all angles, they'll be congruent. If they have all sides, they'll be congruent. If you have a side, side, and an angle, so side, side, angle, and they have to go in that order, side, side, angle, and angle, side, angle, so angle with the side and another angle, they'll be congruent. And the last one, side, side, angle, side. Here's a special note that you should be aware of. In the situation where we are given 2 angles and a side not contained by the 2 angles, we can calculate the measure of the third angle from the fact that the three angles in a triangle have a sum of 180. The grouping now falls into the category angle, side, angle. Okay, in each case, use the information to determine if the triangles are congruent. If they're congruent, state the condition. So whether it's side, 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 angle, side, or angle, side, angle. So here, quickly, we've got angle, side, and angle, side, and angle. So these are congruent. And the condition is angle, side, angle. Let's do C before I do B. So we've got side is equal to side, side is equal to side, and side is equal to side. So these are congruent. Side, side, side. Right here, we've got the same angle, and same angle, with angle, angle, angle. That's not one of our congruency conditions, so not congruent. Because you could, with the same angles, make a bigger triangle, stretch it out a little bit. All right, and this one, we've got side is congruent with side, angle is congruent with angle, and side is congruent with the same side. So these are congruent, and the condition is side, angle, side. All right. So I'm going to do this proof quickly, so try and stay with me. You can pause the video and rewind it if you need to. All right, so it's told us it's a parallelogram, so this is parallel with that, and this is parallel with that. So we've got a couple things here. Remember the Z, if these are parallel, this angle is congruent with that angle. So we can start there with these two. So we know that angle ABD is equal to angle B with angle CDB. And that's the alternate angle theorem. So alternate angle. We know that BD is equal to DB because it's the same side. So BD is equal to DB. Same side. And then we know that this angle is equal to that angle. So angle ADB is equal to angle CBD. Again, that's the alternate angle theorem. So they're congruent. So triangle ABD is congruent with triangle CDB. And what's our reasoning? Well, angle, side, and angle. Okay, a couple things here. I'm just going to prove that something down here first. So triangle, it's a triangle, not an A. Triangle FCD is isosceles. So what do you remember about isosceles? Well, it has the same side. If there's two same sides, these angles are going to be the same. So angle FCD is equal to angle FDC. We're going to call that x degrees. So you can label that in there, x degrees. So therefore, angle ACD, where is angle ACD? Well, it's this one. It's on a straight line, so we're going to do 180 minus x degrees. And then we're going to do the same thing for the other side. So angle BDC is equal to the same, 180 minus x degrees. Because it's on a straight line, and we already figured out x degrees. So 180 minus x equals that angle. Because this entire line is going to equal 180, and we subtract x. So now that we've set that up, we can do our proof. So the first one is AC is equal to BD, and there's both 3 centimeters. Number 2, CD is equal to DC, same side. Third one, we prove that these things are the same. So we can say angle FCD is equal to angle ACD. Sorry, my apologies. Angle BDC. So we need to erase that there. Not those two angles are the same, but these two angles are the same. So angle ACD is equal to angle BDC, and they're both 180 minus x. So triangle ACD is congruent with triangle BDC. And what's our reasoning? Well, we've got a side, angle, and a side. Side, side, angle, side, angle, side. All right? So therefore, AD is equal to BC and its corresponding sides. So there's the lesson. Try the assignment questions and ask me if you have any questions.